Hey everyone, welcome to your next installment of the GoldenGate Tech Talk series. This is your source for informative and timely tech topics about GoldenGate software, data replication, and cloud data integration. The industry-leading data replication software for more than 20 years, GoldenGate is still innovating today and helping thousands of leading brands get the most business value out of their data. As a multi-cloud capable replication engine, GoldenGate helps customers maintain seamless integration across their public clouds. But what makes GoldenGate really special is the breadth and attention to enterprise-class solutions for databases, cloud, big data, NoSQL, and streaming technologies of all kinds, not just Oracle. GoldenGate's rock-solid foundation is the best-in-class for data high availability, high-speed transaction replication, and data warehouse loading. But modern data challenges require the most innovative solutions, and GoldenGate delivers on world-class data lake ingestion, stream data processing for real-time ETL, and advanced stream analytics that include geofencing, time series processing, and machine learning integrations. As a platform for modern data integration, GoldenGate just can't be beat. Well, that's about it for the intro. Let's get on with today's tech topic. Okay, everyone, welcome to today's topic. We've got an exciting one today, actually. We're here to announce the latest capture functionality for GoldenGate. We've now added extract or transaction capture for PostgreSQL, including variations of PostgreSQL for Amazon Aurora as well as Amazon RDS. So during this talk today, we'll run you through the functionality, the new capabilities in the software, and we'll also show you a hands-on demo. We're actually joined today by GoldenGate Product Manager Nishar, who will take us through a demo of how the functionality actually works while using Amazon itself. So thanks again for joining. Let's go ahead and get started. So the newest version of GoldenGate 19.1, we've actually updated the Postgres capabilities. You can, GoldenGate for a long time has been able to deliver data to Postgres using the GoldenGate replicate feature. But now we're also able to capture transactions from PostgreSQL, including cloud derivatives based on Amazon, such as Amazon Aurora, which is the fully managed version, and then Amazon RDS PostgreSQL and Amazon RDS Aurora as well. So all four of those actually are certified for capture, and let's take you through the functionality that we've got embedded in there. One of the things that GoldenGate does, which is quite valuable, is that when we have databases running across different chipsets and different operating systems, GoldenGate will automatically perform the NDA normalization from a mid-tier host. And so the GoldenGate software itself can run separately from the database sources and targets. There's no need to install GoldenGate on the source machine or the target machine. In fact, in the case of cloud, quite often you want to run the GoldenGate software on a dedicated compute instance, which is completely supported, totally possible, using the remote capture and the remote delivery functionality. So it gives you a great way to kind of decouple the operating systems and the chipsets of the variety of different database platforms that you might be replicating from or replicating to. We also have all of the normal GoldenGate heterogeneous support that you heard about in the intro, and any of the transactions or data that's been captured from Postgres is of course instantly available to all of the normal GoldenGate target environments, such as other databases, cloud environments, big data ecosystem, NoSQL engines, as well as stream processing platforms, including the GoldenGate Stream Analytics tool itself. So all of those, again, GoldenGate supports natively as part of the overall GoldenGate platform. As far as the patterns that can be set up with Postgres, it's all of the standard GoldenGate patterns. So these are, pretty typical for any of the database-to-database replication that might be done in Oracle GoldenGate. And when we add Postgres in, it continues to support all of these variety of different configurations. So there could be unidirectional use cases going from a primary to a secondary or perhaps a reporting engine. We support the bidirectional or even the multi-active or what's called the peer-to-peer environments where you've got kind of many-to-many replications. Of course, that does include support for conflict detection and resolution. We support the typical reporting and analytics type patterns, such as the data distribution, say, for an operational data store, or consolidating from an ODS to a data warehouse in the classic kind of Kimball type of data warehouse architecture. And then, of course, we do support the streaming and the messaging frameworks as well for moving database transactions downstream, for example, into microservices-based applications, functions-based services, or even streaming platforms. That's all supported natively in the GoldenGate platform. And when we bring Postgres in, that's all part of the Postgres functionality as well. So let's dig in a little bit to what we can do now with the Postgres capture capabilities. So we are able to capture transactions from PostgreSQL 10 and higher. We support the Linux platform, which is where the GoldenGate components would be installed. And like I mentioned before, we can do the remote capture. So Postgres can be different operating systems and different chipsets. We do support the initial load capabilities of GoldenGate to do the full database instantiation. Vast majority of PostgreSQL data types are supported, including clobs and blobs. So those large object data types, which are popular today in a lot of the modern web-based applications, are fully supported. And then we do support the SSL connection, which is a pretty typical requirement, especially for cloud-based Postgres implementations. Also on the capture side, we do support full globalization in the GoldenGate software, as well as the globalization in Postgres itself. You can wildcard how you set up your extract configurations for which tables you want to read from. You can manage your replication slots or truncation points. This will all coexist with the native PostgreSQL replication, so you don't have to worry about turning any of that off or having any conflicts with the native replication if you're going Postgres to Postgres using some of the built-in functionality. And then you can take care of all of the positioning through LSN, timestamps, or EOFs, just all the typical GoldenGate things. This actually winds up being quite useful if you're replicating downstream into messaging-based systems such as Apache Kafka or even Java Messaging Service, recording of those positioning information. And then GoldenGate, of course, comes built in with the heartbeat information, and all of that is, of course, fully supported with the Postgres implementation. So our customers can, closely monitor lag situations that may arise from time to time when working with databases. On the replicate side, which is for delivery, I mentioned before we do support those multi-master configurations as well as the bidirectional configurations, and really key to handling that is this conflict detection and resolution. So that's a fully supported capability in the tool. We do support what's called the coordinated replicate. That is extremely powerful in terms of high performance for loading into Postgres. We'll talk a little bit about that in just another minute. And then we support batch SQL in the heartbeat table, as I mentioned before. Speaking about performance again, we've seen fantastic results for this being kind of the first iteration of our capture capabilities. In actual real-world situations working with a Fortune 500 automaker, we've seen 400 gigabytes of redo per hour in terms of actual capture performance. And so we're pretty confident that we can keep up with even some of the most demanding Postgres implementations on the planet at this point as far as the transaction volume. Of course, experiences may vary. Each database schema and the way that which data types are used and the way that the tables are laid out may affect capture performance, but in general, we're seeing very good results for this early iteration of the new extract capabilities. And that's actually been one of GoldenGate's strong suits over the years. It's known for extremely high performance on all the platforms that GoldenGate supports, and that's something that we're very much committed to continuing with the Postgres implementation. In regards to the cloud, we do, of course, support Oracle Cloud, so the GoldenGate implementation for Postgres can run natively inside of Oracle Cloud Infrastructure. And GoldenGate supports data delivery into a wide variety of Oracle Cloud Infrastructure targets, including Exadata Cloud Service, our database as a service on virtual machine, as well as bare metal, our autonomous engines such as Autonomous Data Warehouse and Autonomous Transaction Processing, the OCI object storage, as well as the OCI streaming service, are also certified targets for GoldenGate. So what that means is we can work with customers that are running, vanilla Postgres in their own on-premise infrastructure. We can work with customers that are running Amazon Aurora, either fully managed or as part of Amazon RDS. And then, of course, Amazon also hosts Postgres as part of their normal RDS services as well. And GoldenGate can capture from all four of those engines and deliver transactions into the Oracle Cloud starting today. So this is what a typical topology might look like when capturing from AWS. I'm showing two different sources here. In this case, on the left, RDS Postgres, and then AWS Aurora. In this diagram, what we're showing is GoldenGate running from the OCI marketplace for Postgres, and there's a block storage bin attached, which is where GoldenGate will store its trail file information, for example. And then from a delivery perspective, this particular topology is writing the transactions or delivering the transactions into two different engines. One is Autonomous Transaction Processing, and then also Autonomous Data Warehouse, which is used for reporting via the Oracle Analytics Cloud. So from a high level, this topology can be used to support a couple of different use cases, including migrating AWS databases into Oracle ATP, as well as treating your AWS-based applications as a source for analytics that are running in Autonomous Data Warehouse or Autonomous Analytics Cloud. So some pretty exciting new capabilities here. I think it's actually time, why don't we show a hands-on demo of this exact topology. So to do the demo today, we've invited Nishar. Thank you, Nishar, for doing the demo with us. GoldenGate product manager based out of India, and he'll take us through a hands-on demo showing exactly how to set up this new Oracle Postgres functionality with AWS engines as the source, and then our autonomous databases in Oracle as the target. So with that, take it away, Nishar.
This is Nishar here, the GoldenGate product manager. Today I'm going to show you the demo for the Oracle GoldenGate PostgreSQL, which will replicate the data from Amazon RDS PostgreSQL to Oracle ADP services, and I'm going to use the Oracle ADP services today. Before we jump into detail of the demo, the steps and all, I just wanted to show you the overall components that's involved in this demo, right? So as my source and target, I have Amazon RDS, and my target is my Amazon service ADW or ATP. So in this demo, I'm going to use the ATP, and I have my Amazon EC2 instance and my GoldenGate marketplace image. So the GoldenGate for PostgreSQL Classic is installed, configured, and running on Amazon EC2 instance. So the capture for the GoldenGate PostgreSQL will be responsible for reading the transaction log from the Amazon RDS remotely, and then it will dump the trials, the local trial files on the machine, and the data pump will read those local trial files and transport it to the target machine. That is my GoldenGate marketplace image, and I have used the GoldenGate for Oracle microservices installed on this marketplace image. So the receiver server will be configured to read the data sent by the data pump, and it will then dump the 12 files onto the specified location. From there, my remote delivery, the replicate component, will read those 12 files and replicate the data into the ATP service. So this is overall my all the components, the EC2 instance, the GoldenGate marketplace image, and source and targets are Amazon RDS and ATP. You Instead of the Amazon RDS, you can also use the Amazon Aurora as well if you wish. There wouldn't be any changes required into the demo. It's just that you need to provide the credential for the Amazon Aurora. Otherwise, the support remain same for the Amazon RDS or Amazon Aurora. Okay, so these are the steps that I would be performing during the demo, and I just wanted to highlight those steps. So the overall four categories: the configuration of source, configuration of target database, the configuration of GoldenGate and the related path over there for the PostgreSQL, and the configuration of the GoldenGate for Oracle on the microservices. So now let me show you the configuration of the source database and target database. Um, so this is my source database, the Amazon RDS, and this is the parameter which we need to set it, right? The max application slots. You can change it from here. The other parameters required for the OGG PostgreSQL to capture the data from Amazon RDS, you can change it from here. So this is my Amazon RDS, and this is my the marketplace image. This is my public IP. So marketplace image instance has the name OGG19C Aurora, public IP over here, and I would be showing you my Oracle ATP service that I am using in this demo. DB that is running up and running. We don't need to do anything in this DB service. We just need to use the wallet, and we need to place the wallet into our infrastructure, into our marketplace image instance, right? I have this is my microservices marketplace image, which is running up and running. uh, I have two deployments, Oracle 18c and 19c. For demo purpose, I'm going to use the Oracle 19c. That would replicate the data into my ATP service. This is my admin server, and I have predefined created the credentials for the DB ATP underscore WP that I'm going to utilize for my uh, the replicate side, and the user that I'm going to use is GG admin. You need to unlock this user, which is coming predefined into the ATP service, and you need to unlock that user. I have my receiver server, which would show the trail file and the metric server. So let me jump onto the terminals. On the left side, I have my uh, the EC2 instance PostgreSQL GTSJ prompt, and this one is my PL SQL for Amazon RDS. So that's my source table. I don't have any rows right now. This is my directory, my marketplace image instance, my GoldenGate for microservices for Oracle, and this is PL SQL for ATP servers, right? So DB ATP is accessed from here. So there is no rows in the target table as well. Let me show you. So the next thing would be the uh, the Golden Gate for PostgreSQL configuration, as well as the microservices configuration, right? So on the Golden Gate side, I have already my Golden Gate for PostgreSQL up and running. I have added my primary extract, which is responsible for reading the data from Amazon RDS. Let me show you the param file, which is here it is. My credentials, my extract file, which is dumping it into the local folder, dr date, the trial file name is AA, starting with AA, and my table name postgres.table0, right? Let's look at the dr dat folder. there is no trial file available because my extract is not running. Let's run the extract. So my extract is up and running. Let's insert some data into the target table, see whether the trial file is generated or not. And the three records has been inserted. Let's check whether the is the trial file name which is generated. So that's generated over here, AA00. So my primary extract has captured the data from Amazon RDS, and it is now uh, it has dumped the data into the local trial file. The next step would be to uh, configure your pump file, right? So I'll add the pump over here. But before adding the pump, I'll show you the trial file that I'm going to use for the pump. And the name is the ptest pass through. This is my remote host where I want to transport my trial file. That is this right side instance, the marketplace instance, right? The IP address and the port is 9023. That is my receiver server port, that I have configured my receiver server on this particular port. And the trail file that it is going to generate is the .rt. The table obviously is the same Postgres table 0. So let me add the uh, pump test. The trail file that we have to use is AA, the local trail file. Okay, extract is added. Now let's add the remote trail file, and I'm going to use the relative path. So all the trail files which has been transferred from source to the target um, is dumped over here at the default path, and that is U02 trails path. Okay, so my pump is configured, but I have not yet started it because I have to do some configuration on my target side, right? So let's move on to the configure the target side, the microservices. And the first thing is that uh, you have to add the ingress rule to your cloud microservices instance, so that it allows the incoming traffic from your source instance, right, to the target MA instance. So let me show you that. You have to go to your networking, that is over here, and then in networking, the virtual cloud network that you have set up while creating or provisioning your marketplace image. So in my case, I have configured my um, DGVCN. In this VCN, I have my uh, security list. In the security list, I have allowed all the traffics, incoming traffics, for my instance, right? So this is the my source system's IP address, and the port is 9023. That is allowing all the traffic from my source system to this particular port, and that's it. I guess that's what you need to add it into your incoming traffic, so that micro services instance can receive the trial file from your source instance. Uh, that is okay. um, and and then you have to enable the receiver port on your uh, on your target system. So you have to run this command, the sudo firewall command, this ports, which will show you what all ports are open from your side. So 9023 is my receiver port, which I've already opened it. But if you want to add the port, you can also do that by adding it and to the port number. Let's take an example of another port, that's a 9011. Say TCP. And when you list that port again, you would see the newly added port is added, and you can the port as well. Since in my case I have already 9023 open, I have removed the other port. Okay, so that was to enable the port um, that we need to have it. And now verify whether my source and my target system is established, is open for the communication, right? So I have to go and run the command on my source system. That would tell me what is, so this one, this IP address which I'm writing is my target system IP, and my port is 9023 is the port. So as you can see that it shows that this path, this particular path, the IP address and the port is open, and it's connected to this. It's able to connect to that. So now when we run the pump, we should be able to transport our trail file, right? So that has been done. The other important thing that I wanted to show on the ATP side is the wallet information that you need to add into your marketplace image. See that? So this is my uh, deployments, the Aurora 19C deployment, right, that I've been using it. And in this directory, etc., if you go that, you would see the ADB as the folder and SQLnet.aura and DNSTemps.aura. So when you provision the marketplace image, you would have an option to attach your marketplace image with the ADB services. And that's what I've done it. And hence the ADB folder, the wallet information is already been by default added into this uh, marketplace image instance automatically by the marketplace provisioning, right? And what I need to do is I just need to um, open the SQL.aura, and I need to provide the path over here for my deployment, the ADB path. As you can see that etc ADB. Um, that is the only thing that I need to change it, and then you're all set to connect your marketplace image, by this instance, with your ADB, and you can also check and the configure your, as you can see, I can do the testing of whether I am able to connect to my GG admin or not. So GG admin DBATP, you can check the connection. It is successfully connected, right? So that was about how to connect the microservices instance to the ADP. Now let's go and start the pump and verify whether the data has been uh, added into target or not. Okay, so I'm starting my pump p test. It's running, and let's check the folder. So we have the file, the RD, which has been transported by the pump to this target system. Okay, so now since we have the file received by receiver server, we should be able to see the path as well. So now it says that from my EC2 instance, it has delivered the trial file name RT00 to my OG19C Aurora marketplace image, right? And the extract name is post ext. That's what we have. The DB name is Postgres. This is my source schema name, right? So the first part is clear. Now the trail file data has come over here. Now let's go and look at the, so now we need to get the replicate configured, right? And I have already configured my replicate, which is very easy to do through the UI. You can add replicate simply from here, and I would show you the configuration file, the parameter file for my replicate. So Aura 19 rep is my parameter file. DB-ATP is my source credential that we have just tested, and this is my source table, Postgres.table0, and my target is ggAdmin table0. So let's go and start the replicate, which will read the data from the local trail file RT. So now it is up and running the replicate, and let's check whether it has processed the records or not. We can do that by replicate is running through the PMS server, and I would be opening the PMS server um, for the replicate or a 19 wrap, right? As you can see that there was some peak of the data over here, the IO count and everything happened. Let's check the database statistics for that. It has done the 3 inserts which we have inserted in our trail file. So the records has been inserted into the ATP service. Let's go and check the inserts into the ATP database through the SQL plus. Select, and here is the 3 records. So in this demo we have seen the replication successfully captured the data from Amazon RDS to the Oracle ADB service, the ATP service, using the GoldenGate for PostgreSQL. Thank you very much for seeing my video.
Hey everyone, thanks again for tuning in to this edition of the GoldenGate Tech Talk series. Be sure to check out all the other cool tech talks that are out there and stay tuned for more as they become available.